Good morning. We're here with Dr. Fred Wentorf here from Zimmer Biomet, and he's going to give us a tour and show us some of the great things that Zimmer's doing and talk to us about the connections with Grace College. Good morning.
Good morning. Morning, Rick. So we're gonna start here with some of our testing equipment here. So this is kind of a unique testing lab here. So we're actually testing a knee implant. So a femur and a tibia here that we make here at Zimmer Biomet, trying to understand how it works. And again, this is a unique testing system. This really is no company in the orthopedic industry has this internally, and even uniquely to academics as well. This is a one-of-a-kind testing frame. So what this allows us to do is actually simulate what's happening in our real knee joint. We're actually applying the same loads, moments, and motion that you and I would during walking. So, and kind of the reason we're doing that is we're trying to understand how the implants really work in our bodies and make it really relevant to this. And so the idea is you can take this input and help us design better implants. So that's why we need to have relevant inputs. So like the idea of what you and I walking, what it really does. And so one of the questions we're trying to look at here is, if you look at here, so you have a femoral component, then you have your polyethylene and your tibial component, and then kind of a synthetic bone model. So one of the things we're trying to look at here is normally between an implant and the bone, you're going to put cement. And the idea is that cement kind of helps you kind of deal with abnormalities in the cut. So it makes it, if it's not perfect, just like woodworking, if it's not perfect, you can use the cement to kind of make it perfect. And it also helps it to adhere to that. But the downside of cement is it's the strongest the day you put it in. So it's just getting weaker from then on.
Okay.
Which is not what we'd like to have from an implant. Obviously, we'd like it to last as long as possible. So the way to do that is actually to have biologic ingrowth between the implant and the bone. There's lots of benefits of that, but one of the struggles from a biomechanical perspective is for the bone to grow into it, it needs to be a really stable construct. So when we're talking about a stable construct, what that means is there can only be a very, very small amount of motion between the tibial implant here in this bone model. And when I'm talking small, I'm saying sub-millimeter, so like in microns. So that's the cool thing. What we're trying to do here is during this level walking simulation, how much is this implant moving with this bone? And the cool part is it needs to move less than 150 microns to actually get good bone ingrowth. So what we're doing here is trying to test different loadings, different models, and different designs to figure out what actually reduces that amount of motion to actually get a good biologic fixation. And this right now is actually just tearing itself to make sure what its loads are, make sure its loads are right, and then go back down and test again. We're running about 2,000 cycles of level walking. It has nothing to do with how long a patient moves. It's just a simulation to understand how much this testing does over time.
So talk to us about the size of the machine.
Yeah, no, it is an impressive machine, but the cool part to really understand is you need something this big to really replicate what happens at our knee joint. So when we're just walking, basically the load that comes through our knee joint is over 3 times our body weight. So the idea, so saying that's depending on your body weight, could be up to 750 pounds. So the idea of it needs to be this big to actually apply the loads that God made our joints. That's the really coolest thing to really understand, and one of the things that just you're awestruck by how our body is built is it takes something this big to replicate what our body does very naturally. One of the things we'll emphasize here at the new Grace Engineering program is the idea to be able to have a small instrument class sizes in school and have that interaction for the students, but also have interaction and work with cutting edge equipment. So the idea, we have billion-dollar companies here in town that do very sophisticated work. The idea is that we will be able to actually interact with that as Grace program, Grace Engineering program, and students. So the idea we can take data from some of these experiments, analyze them, and actually work in these labs as well is the idea. And one thing that I'm really hopeful, very excited about the potential of the Grace Engineering program to be a very, very unique program, having a very small, intimate class sizes, but having cutting-edge equipment. I think that's something that will make the Grace program exceptional.
All right, can you tell us a little bit about your role at Grace College and what that's going to look like?
Sure, no, I'm very excited. So I'm taking on a new role, so I'm actually being the director chairman of the new engineering department at Grace. I'm very excited about that. The idea of being able to train and educate the new engineers, new generation of engineers is awesome. And one of the things I'm really excited about is integrating my connections and background in the industry here in town with our education of our new students. So the idea of being able to have them an intimate relationship with the companies, which means having our students coming in here and doing research, doing work, and the idea of being able to use data from these companies and it really make their experience very unique. The idea of having, again, a small class sizes being Grace, but having actually world-class, cutting-edge equipment, data, questions that you're not going to get at other places is something that's very, very unique. I'm very excited about. Yeah, and so that's, I'm very excited to make this move from industry to Grace to really be a mentor, partner, pour into students, and make a next generation of Christian engineers.
That is incredible. I think that'll be an awesome opportunity for our students, and Dr. Wentorf, we thank you for your time.
Yeah, thank you very much.